Thank you. Thank you. Thank you for being here. I saw some of you at the bar last night. It looked like a lot of fun. I'm curious how many of you just came here straight from the bar, but I appreciate that. So my name is Andrei Bondarev. I traveled here from South Florida. I'm very grateful to be here. Thank you for having me. Thank you to the organizers. This has been a phenomenal conference, and I really enjoy the city. I love it. All right, so today we'll talk about building LLM-powered applications in Ruby. So I started out my career building Rails applications 13 years ago for the U.S. Department of Health and Human Services, building public-facing applications for millions of consumers. Then I moved on to continue building Rails applications at USA Today. Does anyone remember Spree? Sean Schofield, who was the original author, hired me, and I worked with one of the most amazing Rails teams at the time. Worked at a couple other Rails places. So we're going to talk about generative AI. So what is generative AI? So it is a type of artificial intelligence that generates text, audio, video, etc. And for the purposes of this presentation, we'll just focus on text. So large language models are deep artificial learning, deep learning artificial neural networks with a general purpose language understanding and generation. And they exploded in popularity after the 2017 Google paper, Attention is All You Need, and the underlying architecture is called transformers. We're not going to dive into it. So the generative AI impact is that all of a sudden you were able to deploy commercial production grade systems in just a couple days. So previously, when you had to spend about a month collecting data, about 3 months training data, and about 3 months deploying and then optimizing those models to run on your hardware, well, now you can use APIs and you can get something into POC state or production state within a couple of days. So LLMs excel at a bunch of different tasks. I think some of the tasks they're really good at are, for example, structuring data. So taking unstructured data and converting it to a structured format, taking paragraphs of text and returning JSON or YAML, something that developers can consume. They're pretty great at summarizing text as well. You could send it a short narrative and get a summary back. Classifying data, so bucketing data depending on a certain kind of enum, translating languages, generating content, answering questions, chatbot style. So I'd like to present you a vision where I think this is going, and I don't think anyone truly knows where this is going. So I don't want you to get kind of tied up in the implementation details. I want you to consider this holistically. So I think that generative AI is going to become a part of every single tech stack, the way the databases, the cache, encryption, queues, Lambda functions, storage, and the protocols are. So every tech stack is going to have this running process that it's going to rely on for certain things. So the O2 investment firm presents this vision where it's a crucial part of the application architecture, and the developers are building applications on top of these AI systems. So here's an example. So In every single project of ours, we've got if-else statements, and you have to enumerate all the different options. It's a finite amount of options, and depending on any given input, you either arrive at output 1 or output 2. So with AI, we have some flexibility to consider more ambiguity or more vagueness for the any given input that comes in. So for example, given any input and an amount of a number of different outcomes or methods, the AI will pick the best suitable candidate. So even for input that it's never seen before. So for example, if it's an AI agent, you could have it write a file, approve a document, text my partner. So this has always been the promise of Rails, is that for business owners, your Rails teams should mostly focus on writing business logic. We don't want developers figuring out engineering problems for the sake of figuring out engineering problems. So developers focus on writing business logic and not reinventing engineering solutions. So the old world before AI has always been business logics in fat models or service objects, and it's kind of sprinkled all over the project. And the new world is I'm going to propose that some of the business logic is going to go into prompts. So in this example, where this is a simulated e-commerce store, and we have the AI agent in the middle orchestrating the business logic and sending messages between the different systems that e-commerce store might connect with. So for example, just about any e-commerce store connects to a payment gateway via an API, connects to an inventory management system via an API, accounting systems, shipping service. So I'm proposing that you would be able to write out your standard operating procedures for your business, put it in the prompt, and then just like in the diagram, you would have AI orchestrate those, orchestrate the execution for handling orders, processing returns, handling the customer loyalty program, etc. So this takes us to AI agents. And AI agents are autonomous or semi-autonomous general purpose LLM-powered programs. They can use tools, which are basically APIs and integrations via function calling. And they work best with powerful LLMs, and the OpenAI GPT-4 is kind of the leader right now, although it changes every week. And they can be used to automate workflows and business processes. So agents are, anyone that's ever tried to build them, they're pretty unreliable. And this is the way I think about this, is they become more reliable, the upper triangle, as the number of tasks or responsibilities that these agents are responsible for shrinks or decreases. So you kind of narrow down the set of responsibilities that AI agents execute, or the decision tree that the agent has to go down. So if you look at this chart, on the x-axis, we have a focused agent, so maybe a single task or dual task agent on the left-hand side on the x-axis, and a general purpose agent towards the right side on the x-axis. And basically, I think we can, this is at least POC ready. So the upper left quadrant and the bottom right, and if you get a general purpose reliable agent, well, that's AGI. So the adoption has been still pretty slow. And this is due to a number of different reasons. It's a fast-changing field, so if you decide to invest into this technology right now, you're chasing a moving target because everything changes every week. There's a lot of ambiguity around the IP ownership or copyright ownership. So who owns the derivative of work that the AI has generated, whether it's text or imagery, because these models are, I believe, trained on some copyrighted data, even though they don't tell us so. There's a lack of tooling for developers to build applications. And also it's risky. So in some instances where large projects are rolled out, like the Air Canada chatbot that told the customer wrong information, and then the customer ended up suing the company for money. Or also below there's an example of a user convincing the General Motors chatbot to sell him a car for $1, and you either give away a $40,000 car or you suffer reputational damage. So of course the first option was safer. I hate calling this prompt engineering. This is prompt alchemy. This is not an engineering discipline, given how random it is. You change a couple of words and you get a completely different output. Look at this research paper. I mean, you're telling the model to take a deep breath and think of this problem carefully, and it improves the results. It doesn't make sense. And when you try to ask people, why does this happen? No one knows. And they just say, well, it's in the training data. But how does this happen? No one knows. There's jailbreaking techniques, so basically getting a model to do or say unintended things. For example, this paper came out of Anthropic. They coined this term many-shot jailbreaking. So if you go to OpenAI right now and ask it how to make a bomb, I don't want to do that because I don't want to get someone show up at my door the next day. But you can trick it into telling you how to do that by listing a bunch of examples as if it did tell you how to do all these malicious things. And then it'll gladly tell you how to make a bomb. So, of course, there's a lot of deficiencies that we've looked at. There's hallucinations, because the models are trained in a snapshot in time. The data gets outdated pretty quickly. So, for example, GPT-4 is trained on data up through April 2023, and in some instances, you wanted to utilize the relevant knowledge, your proprietary knowledge, and it has no means of knowing that right out of the box. So enter what's become popular, this methodology called retrieval augmented generation, or short for RAG. It's very simple. It's when you take relevant knowledge, your proprietary knowledge, you inject it into the prompt along with the user's original question, and then you have the model use that knowledge to generate a relevant, accurate answer to the user's question. So, for example, a popular use case is building QA systems on top of your proprietary corporate data. So if I want to find out how long the paternity leave is at my company, the GPT-4 is not going to know that. It's buried down in the HR documents. So this is RAG. So to break this down, to go a little bit deeper, double click on that. It works by first generating vector embeddings from the user's question. Then you typically store your proprietary data in a vector database. So you would execute a similarity search. You would find the relevant documents, and then you would construct a RAG prompt, and then that's what your LLM model would use. So let's dive into some of those things. So what are vector embeddings? So vector embeddings are a machine learning technique to cluster data by its semantic meaning. So LLMs encode meaning behind words or texts and place it somewhere in the embedding space or vector space. And vector space is a multi-dimensional space. So for example, the OpenAI's ADA model is 1536 dimensions large. So for example, we could take this string. The Ruby programming language is 30 years old and has stood the test of time. Isn't that true? And we run it through an embedding model, and it spits out a vector of length 1536. So because a human mind can only visualize 2D or 3D spaces, we're unable to show what a 1500 dimensional space looks like. But if it was reduced down to a 3D dimensional space, then you can see that our blue dot is clustered by the meaning along these other points. So this is also called a lens. Can you guys hear me okay? And when we're doing semantic search, also known as vector search, is we're calculating the distance from your query to the different points found in the vector database, found in the latent space. And there's different ways of doing that. You can calculate the Manhattan, Euclidean, or cosine similarity distance. And then now that you've obtained relevant documents, you merge it as the context into your prompt. Typically, the instructions at the top, you would drive some sort of LLM behavior. So you could tell it to reply concise, be concise and straight to the point. And then it would complete the rest of the answer. So that's RAG. This is what naive RAG is. So again, a query comes in, you run it through the embedding model, you run similarity search against your vector store, where your proprietary corporate documents have been indexed into. And you take those documents, you merge them into the context, package it up as a prompt, give it to the LLM, and derive the answer. So evaluations are very difficult. Typically, people rely on human feedback. So if you've used ChatGPT, you know that every answer comes with a upvote and downvote, and this is what they use to fine-tune the model and figure out how well their models are performing. If you're building a system, you can then use GPT-4 to assess or critique itself. So you could say, this is how my model performed. This is how my model answered this question. You could send it back to the GPT-4 and say, is this a satisfactory answer? How would you rate it? One of the few quantitative ways to do this, and as engineers, we all want we want to take a scientific approach, and one of the few ways is this technique called RAGAS, and it stands for RAG assessment, which you measure 3 different metrics, which is faithfulness. So making sure that the retrieved context can act as a justification for the generated answer, context relevance. So making sure that the context is focused with little or no, little to no irrelevant information, and then answer relevance, making sure that the answer addresses the actual question. And you run those 3 different metrics, you combine them, and you get a RAGAS score. So there's other advanced strategies where this is just one of them. Other advanced RAG strategies where you can use 2 different indices. One that just contains summaries. So for example, you generate a summary off of every single corporate doc of yours. And then the other index that contains actual chunked data, and then you first run similarity search against the summaries, get the pointers to the more detailed index, yank the data out into a context, package it up into a prompt, send it off, get your answer back. So everyone talks about chatbots, all these enterprises that have fallen face into mud, into puddle, like Air Canada, GM. They're all building chatbots because it's sexy. But I actually think that when you're interacting with a human, you open up your prompt for prompt injection, prompt hacking, and there's just an infinite amount of different scenarios. So I actually think that the near term is running these models behind the scenes and controlling your prompts. So I'm not sure that we're going to go, at least in the near term, towards these open chat experiences where you're a customer sales associate and you're chatting with this AI bot and you say, reach out to this client, draft this email, create a presentation deck. I actually think you're going to have some sort of a control panel, right? We're closing down the set of tasks. the set of responsibilities that the AI agent is responsible for to make these systems more reliable. So I think you're going to have a control panel with quick links, kind of most common business processes that are just a little bit more intelligent than what the current systems are behind the scenes. So enter LangChain RB. I'm going to be humbled to say that it is the most popular Ruby solution to build LLM powered applications. The use cases are general interfacing with LLMs. You can build agents. You can build RAG systems. And our approach is being vendor agnostic. Everything changes so quickly. We don't know who the leading providers are, whether it's going to be OpenAI or Google or a smaller French startup called Mistral. So we're ready to kind of support all of them. And we're going to try to stick with best practices and stay on top of the almost daily emergent research. And of course, in the greatest Ruby on Rails fashion, batteries included. So the LangChain RB approach is a common interface for LLMs. So you could just pick your provider and the methods adhere to the same signature. Same with vector databases, pick your poison. You can add data by just calling add text and then run similarity search. And then if you do .ask, that executes a naive RAG. So we're going to do some coding. I'm going to walk you through a short kind of e-commerce AI assistant that I've built. I'll try to kind of explain how it's built, and then we'll run it and see what kind of results we get. So if you'd like to look at the repo, just scan this QR code. It's not necessary. All right. Is this big enough? Can you guys hear me okay? Okay, so let's look at some code. Let's see. Just trying to close all files for now. Okay, so what we did here is we pulled the LangChain RB gem in. We pulled a mainstream gem that validates that an address is a valid address. We pulled in the underlying Ruby OpenAI gem. I was debugging, so of course I need pry. We have SQLite, SQL.env and the mail gem. And in our setup DB file, we create a simple SQL database, SQLite database. So we have a products table, we have an orders table, we have an order items table, and a customers table. And we create some dummy SKUs with price and quantity. And this AI assistant is going to run this kind of tiny simulated e-commerce store and orchestrate the the business logic between the different services. And we're calling the store Nerds and Threads that makes graphic, nerdy t-shirts for software engineers that like working from home. So that's the background. And, oh, okay. That's a lot of it's a lot of keys that I'm going to have to change shortly after. All we need is the OpenAI key and the database name, and we're calling it Nerds and Threads. So we've got very simple models to represent those tables. So customer has many orders. An order belongs to a customer and has many order items. An order item belongs to order and belongs to a product. And a product has many order items. So we're gonna represent our services as tools. And a tool is a collection of functions. So for example, we can take a look at our customer management tool. It inherits from LangChain toolbase and points to a customer management JSON that I'll show in a second. And it has just two methods. Creating a customer. So we create a customer by passing the name and the email and create it in the database and send this JSON response. Find customer, which we find a customer by email and send the hash back. And what the JSON does is it describes these functions in the Open API spec, right? So Swagger, Open API. And we will be sending this data, we will be sending these signatures, our tool signatures, to the LLM. And that basically explains what these methods are for and how to use them. So in this example, you could see that the create customer would give it a description that it's a part of the customer management service and it creates a new customer with a given name. And then we specify the name and the email parameters that are required. And same thing for find customer. So this is a tool. And what LangChain RB is doing here is it's kind of orchestrating that connection, right? Where you can pass a tool and behind the scenes it uses this JSON to match it with the methods in the class and orchestrate this function calling. So we have another service called email service that uses the Ruby mail gem. And it takes the customer ID and the order ID, and it just sends an email with some order details. Thank you for shopping at Nerds and Threads. We have an inventory management tool that you can use to update inventory with new quantity or find a product by SKU and get a hash back. Same thing in this JSON here. It describes the interface. Order management tool that you can use to create an order, mark the order as refunded, or find it in the database. payment gateway that has charge customer, refund customer, and issue store credit methods. Same thing, open API spec of these 3 different methods, explaining to the large language model what they are and what they can be used for. And the shipping service that validates the address. This is kind of a nice to have. Creates a shipping label and creates a return label. So let's give it a run and see how well it performs. So I have saved some of these instructions in the README because I'm not going to watch you painfully type out every single thing. So I'll just make sure that that database doesn't exist. Is the terminal big enough for everyone to see? Okay, so I'm going to run the setup DB to create our database. And I'm going to run our main.rb file. And let's just check the product. The database is there. The models work. So now what we're going to do is we're going to instantiate the LLM client. So we're going to say LangChain LB AI.new API key. And default options, we're going to use the chat completion model GPT-4 Turbo. Let me just confirm that I typed the right thing. Chat completion model name. Oh, okay. So the LLM client is there. So if we just want to send it a simple message, we can, and it responds back with, hello, how can I help you today? We can also embed data. Sorry, not the, yeah, let's skip this for now. So in the instructions here, I wrote out what our store, how our store is gonna operate. So we're going to say that we're going to tell the LLM that it is an AI that runs an e-commerce store called Nerds and Threads that sells comfy, nerdy t-shirts for software engineers that work from home. You have access to the shipping service, inventory service, order management, payment gateway, email service, and customer management systems. And it is responsible for processing orders. Follow these exact procedures below, and we give it steps to execute the order, step by step. So create the customer account if it doesn't exist, check inventory for items, calculate the total amount, charge the customer, create the order, create a shipping label, and send an email notification to the customer. So I will insert these directions into a terminal. And let's instantiate our assistant, LangChain assistant, which is going to use those instructions. It's going to use the instance of the LLM that we've instantiated, and it's going to use these 6 different tools. And the thread a thread just keeps track of the different messages. I'm going to clear the screen. I'm going to paste this in. So we have the assistant. So let's execute the first order, which is myself just purchased 5 t-shirts with this, and my address is this address in New York. Not a real address, and not my address. I'm going to clear the screen and paste this in. So sending a call to LangChain OpenAI, looking up customer record, sending a call to LangChain, creating customer record, validating address, charging customer, updating inventory. So we will take a look at. Okay, so let's see what happened. So I'm going to skip all these different calls to the LLM, but we looked up a customer record. It didn't exist. We created it. We looked up the SKU to get the price for this item. We then called the shipping service to validate the address. And then we charged the customer for this amount. And I'll show you that it's 5 t-shirts at that price amounts to this amount. We then updated inventory with updated quantity. We created the order record. We created a shipping label, which calls behind the scenes, it calls when you create a shipping label, it calls the validating address method again. And then we sent an email notification. And if we look at, these are all the messages that were kind of exchanged. I understand it's not super readable, but this is the original prompt, system prompt that we wrote out as the instructions to our AI assistant. We then sent the message saying that I had purchased 5 t-shirts, and then this assistant is a message that came back from the LLM, and it calls these methods. So it tells us that I want you to find customer with this email, and then we match it with that tool or that API. We serialize these arguments and call that method in that tool with those arguments and send back the result. So our tool actually returned customer not found. Then the assistant said, okay, create the customer. This is the name, this is the email. We said, okay, we just did. Here's the customer ID. The assistant then said, okay, find this product with this SKU, and then also call validate address. This is known as parallel functions. We said, okay, here's the SKU, but total we have in the inventory is 10. Here's the price. So if you take 5 by 24, it's $24.95. So this is the this tool validated the address and sent true as yes, this address is valid. And this tool call ID is a pointer to the corresponding tool calls. So that's how the LLM is able to tell that whatever we send it, that output corresponds to a specific function call. The assistant then said, okay, charge the customer for the total amount of $124.95. Here's the customer ID. We said, okay, we charged them for that amount, random UUID for transaction ID. The assistant then said, update the inventory and the new quantity, since we just sold 5 t-shirts, is 5. So update this queue with quantity of 5. Create the order with these order items. So we just sold 5 items of this SKU. So I think this was supposed to be a hash. Okay, so the create order, so the order management create order call returns success true with this order ID. And the update inventory returns the product hash, which contains the quantity, but I forgot to call .hash on it. The assistant then said, create a shipping label with this address and this customer ID. And there's an enum where it can choose from shipping provider. We said, okay, true. Here's the tracking number, random UUID. And then the assistant calls send email, and then this email gets drafted. And then taking all of that, the assistant then just says, my order has been successfully processed. Here's a summary, customer ID, order ID, total charged, shipping provider, and you got an email. Thank you for choosing Nerds and Threads. So I'm gonna clear this thread. And the reason why I'm doing that is because I wanna delete all this chat history. So otherwise this chat history will be sent back to the LLM. And recall, as I said, in order to make these things reliable, you have to close down the set of responsibilities, not give them a very massive prompt, because it'll get overwhelmed and it'll get confused. So these are the limitations, and what we're trying to do is we're trying to find that sweet spot where it can actually be usable. And again, this original message that I sent, I don't think it should be an open chat interface where someone runs this e-commerce store and they chat with the system. There's just too many permutations, too many possibilities for it to go wrong. Imagine that this gets sent by a different system in this format, right? And we can illustrate that this works 9 times out of 10. So I'm gonna clear this thread, and I'm gonna reset the instructions because that gets set as the system message. So if we look at the thread messages with no extra letter S, then it just contains that same prompt. Again, operating procedures for our simulated e-commerce store. So then my friend Steven comes in and he's purchasing this SKU and this SKU. I don't believe this is Steven's real Berlin address. And I'll talk through it in a second. End it with sending an email. Okay, let's take a look at this. Looking up customer record for Steven. Looking up the product SKU. Looking up a different product SKU. Create the customer record for this email, this new email. Validate this Berlin address. Update the inventory. So the original quantity was 5. So Steven purchased 2 of these SKUs. So it updates the inventory with the new quantity. And this SKU of the original quantity was 3, and Steven purchased 1 of these SKUs. So the new quantity is 2 units. Charge him. And this was calculated correctly, I believe. Create the order, create the shipping label, send an email. So I'm going to clear the thread again, and we're going to try slightly different instructions. So we're going to try these return order instructions. So let's take a look at them. The first part is the same. You're operating nerds and threads. You have access to these services, etc. Follow these exact procedures below for returning an order. So look up the order, calculate the total amount, refund the payment, mark the order as refunded. I'm going to insert these instructions. And I'm going to set them. Let's just verify that they're in there. And Steven changed his mind, and he's returning his order. Looking up the order, looking up the SKU, looking up the other SKU, refunding the payment gateway, and refunding the order, which just marks the order as refunded. And this is all actually saved in the database, powered by SQLite. And last thing, let's clear the thread again. Reset the instructions. And we got a new inventory shipment. Let's update some SKUs. So inventory update. updating this queue, updating this queue, updating this queue. And then at the end, it just tells us the inventory has been successfully updated. You might ask, why didn't we just put these return steps into here? And again, this is what I've kept referring to, is these systems are still pretty dumb, and we don't want to overwhelm them. And we're trying to figure out that sweet spot where it could still be productive and reliable, right? If you remember my x-axis, y-axis, we want to be in reliable but focused quadrant, right? So focused interactions. So perhaps you have two agents, one that is just laser focused on completing orders and one that's just laser focused on returning orders, and that's all they do. But they're not telling you what the meaning of life is and dealing with all of it and consuming the massive business operating procedures manual. So I would love to check this out and poke holes in it and give me some feedback if you want, if you can. Okay, so why Ruby? Well, I love the language. I've been doing this for a very long time. I love how pragmatic our community is. We focus on business problems and delivering business value and not over-engineering. We have strong OOP principles. I think of such great books like Practice Object-Oriented Programming in Ruby by Sandy Metz. A lot of Python people come from research and academia. If you've looked at some of those projects, I'm not saying everyone does it, but I don't see good patterns. I see methods that are hundreds of lines long and not tested, and I think we have good mental models that could give us some new ways of thinking about these agents and LLMs. I tweeted this thing earlier in the year. Everyone says we're so far away from Python. They have all these amazing libraries, and I said, well, you can, if rewriting some of them, if you're yearning for a utility in Python and it doesn't exist in Ruby, just get ChatGPT to rewrite it. So a Ruby developer is sad a Python library doesn't exist in Ruby. They paste the code file by file into ChatGPT, ask it to rewrite it, and with a couple tweaks, you can run it, and the Ruby developer is happy now. I've done it a couple times. It works not bad. Okay, so some of the things I've learned from running this modest open source project is you got to be responsive. So when people ask you questions or issue pull requests or open issues, you got to be responsive because you have them for a finite attention span. You got to be friendly. You got to be welcoming. and you got to be helpful. You got to jump on these opportunities to help people and go out of your way to deliver value. Thank you for all of these different humans that have contributed to the project. And here's our Discord, where we talk about the project and kind of what we're seeing in the AI, LLM, Gen AI space. And the last thing that I want to leave you with is we do not have it all figured out yet, but we're optimistic. Thank you.
All right. Any question?
Thanks for the great talk. In your example, you've built a system that sends the instructions to LLM for each incoming request. And I wonder, because potentially you could have asked LLM once to generate Ruby code that performs those instructions. And I wonder what trade-offs are here.
Yeah, so if you didn't connect the dots, or maybe I wasn't super clear, this is what we tried to do, right? So we had an Nerds and Threads e-commerce AI assistant orchestrating messages. And there was nothing in the code that had this business logic, how this e-commerce store should operate. So, you know, I'm actually very interested in this type of angle to solving the problem. I think a lot of companies are pursuing generating the code and then saving the code. I'm actually curious, what would it be like without that? So I'm actually curious what it would be like to generate the execution, right? And I will ask, why do you even need to save the code? So what we're doing as Rails developers is stringing APIs together, right? APIs to the database, mail service, this service, that service. And like I've stated in this slide, right? We're focusing on building business logic. So that was my attempt to illustrate this concept that can we write out business logic in prompts, and then can the execution be inferred? And inference is what the LLM is doing as it's predicting next tokens. That's called inference. Thank you.
All right, guys. Sorry, Steven, we have to move the discussions and questions to the hall as we are over time. That's what I heard. There was a whisper. Let's thank Andrei Bondarev, your Ruby AI guy, for explaining this. Thank you very much.